You're already dead to the universe. Not metaphorically, not poetically, but in the most literal, cold, mathematical sense that physics allows. Every atom in your body was forged in a star that exploded before your sun even existed. You were never really born, you were rearranged, and Richard Feynman knew that. He knew it in his bones, in that restless, laughing, furious way of his, and it terrified him, and it delighted him, and he spent the better part of his extraordinary life trying to drag the rest of us up to that same dizzying ledge so we could look over the edge together and feel what he felt, this impossible, gorgeous, nauseating sensation of being a conscious creature in a universe that had absolutely no obligation to make sense to. Most people never get there. Most people go their entire lives without once feeling the full weight of what it means to exist in a cosmos this size, this age, this strange. And Feynman thought that was the real tragedy. Not death, not suffering, not war or famine, or any of the things we usually call tragic. The real tragedy, he believed, was a human mind that stopped asking questions. A mind that looked up at the night sky and felt nothing but mild aesthetic appreciation, like admiring a screensaver, and then went back to bed. That to him was a kind of death far worse than the biological kind. So let's start there. Let's start with the sky. Picture this. It is late. Really late, the kind of late where the world has gone quiet and the air has that particular cold sharpness to it. The kind that gets into your lungs and reminds you that you are a warm, fragile, temporary thing in a very cold universe. You step outside, maybe in a backyard, maybe on a rooftop, maybe in a field somewhere far enough from the city that the light pollution hasn't swallowed everything, and you look up and you see them, the stars. Now, most people look at stars and feel something vague and pleasant. Romantic, maybe. Peaceful, maybe. A gentle sense of something larger than themselves, which is nice. Which is fine, which is completely human. But Feynman looked at stars and felt something altogether different. He felt the physics of them. He felt the nuclear furnaces burning inside each one of those points of light, the gravity crushing hydrogen into helium at pressures so extreme they make the word extreme sound embarrassingly inadequate. He felt the billions of years. He felt the distances not as numbers, but as a visceral, almost physical sensation of separation. And he wanted you to feel that too. Not instead of the romance or the peace, but in addition to it. Because he argued, knowing what something really is does not make it less beautiful. It makes it more beautiful. It makes it beautiful in a way that actually costs you something. In a way that changes you. Bueno, here's where it gets interesting. Here's where Feynman would lean forward in that way he had, that slightly conspiratorial, delighted lean, as if he were about to tell you the best secret in the world, and he would say something like, the stars are not just far away. They are far away in a direction that your brain literally cannot process. Your brain evolved to navigate a savanna. It evolved to track prey across maybe a few kilometers, to estimate whether that shadow in the tall grass is a lion or a rock, to judge whether a berry is safe to eat. Your brain did not evolve to comprehend 100 billion light years. It is not built for that. And so when you look at the night sky and you feel only mild wonder, do not blame yourself. Blame the savanna. Blame the fact that natural selection had absolutely no reason to equip you with genuine cosmic intuition. But here's the thing, and this is where Feynman's particular genius comes in. He believed you could build that intuition anyway. Not through some mystical experience, not through drugs or meditation, or staring at sunsets, but through the hard, joyful, occasionally maddening work of actually understanding the mathematics and the physics underneath reality. He believed that if you really truly understood what the equations were telling you, if you sat with them long enough and wrestled with them honestly enough, you would eventually arrive at a place of genuine cosmic vertigo that no amount of poetic language could give you. And yet, and this is the first of many reversals we need to sit with, the very tools he was offering us, the equations, the models, the frameworks of quantum mechanics and general relativity, those tools revealed something so deeply disturbing about the nature of reality that Feynman himself sometimes seemed unsure whether he had found the truth or simply a more precise and elaborate form of confusion. There's a word for what he discovered, a specific word for the condition that the universe seemed to be in at its most fundamental level, but I will get to that later, because first you need to understand how far down the rabbit hole actually goes. If you're watching this and you have never truly reckoned with the scale of the observable universe, I want you to stop for a moment and appreciate the fact that you're about to because this is not something most people ever do. Most people hear the number, they hear something like 93 billion light years across, and they nod and they move on, and the number does absolutely nothing to them because numbers that large are simply outside the range of human feeling. They are technically comprehensible but emotionally inert. So let's try Feynman's approach instead. Let's try analogy. Imagine the entire observable universe compressed down to the size of the Earth. All of it. Every galaxy, every cluster of galaxies, every filament of dark matter and cosmic web, compressed down to a sphere about 13,000 kilometers across. On that scale, the Milky Way, our galaxy, our home, would be smaller than a single atom. Not a small atom, not even a medium atom. A hydrogen atom, the smallest kind. And within that atom-sized galaxy, our solar system would be a structure so small that it would be invisible to any instrument we currently possess. And on that invisible structure, you're a thing so small that the concept of smallness itself starts to break down. Now, Feynman would tell you that this is not meant to make you feel worthless. Quite the opposite. He would say that the remarkable thing is not how small you are, but the fact that you are the part of the universe that knows it is this big. You are the universe looking at itself. And he found that genuinely almost unbearably wonderful. But he was also honest enough to follow that wonder into its darker implications because the universe being this big raises a question that once you hear it properly, never quite lets you go. The question is simple on the surface. It is a question a child could ask, and it is this: where's everybody else? Espera, let's sit with that for a second. Because if the universe is this vast, if there are something like 2 trillion galaxies within the observable universe alone, and if even a tiny fraction of the stars in those galaxies have planets, and if even a tiny fraction of those planets have the right conditions for chemistry to become biology, then the sheer number of opportunities for life to have arisen is so staggering that the word astronomical doesn't come close to capturing it. The number is beyond astronomical. The number is almost theological in its immensity. And yet, and here's where the floor drops out from under you, we hear nothing. We detect nothing. We find nothing. In over 60 years of searching the sky with increasingly sensitive instruments, in scanning billions of radio frequencies, in looking for laser signals and heat signatures and atmospheric biosignatures, we have found exactly 0 confirmed evidence of any other technological civilization anywhere in the universe. Silence. Total, absolute, unbroken silence. Now, if you're the kind of person who hears that and thinks, well, the universe is big, maybe we just haven't looked in the right places yet, then Feynman would nod at you patiently and say, yes, that is possible. That is one hypothesis, but you have not yet truly sat with the numbers, because the silence is not just a little surprising, it is deeply, profoundly, statistically scandalous. The physicist Enrico Fermi, eating lunch one day at Los Alamos, did a rough calculation on a napkin and arrived at a conclusion that has haunted the scientific community ever since. Given the age of the galaxy, given the number of stars, given reasonable assumptions about the probability of life arising and civilizations developing, there should be, by any reasonable estimate, thousands or even millions of detectable civilizations in the Milky Way alone. Not somewhere in the distant universe, in our galaxy, our neighborhood. And we should have heard from them by now. We should have seen their signals, their probes, their megastructures, their waste heat. We should, at minimum, have some faint echo of their existence, and we have nothing. Dejam pensar un momento, because the implications of that silence are something most people are not prepared to face. And I do not mean that in a condescending way. I mean it in the sense that Feynman meant it when he said that the first step to real understanding is the willingness to be genuinely disturbed. If the universe is teeming with the potential for life and yet appears to be completely silent, one of two things must be true, and both of them are terrifying. Either life is so vanishingly rare that we are, for all practical purposes, alone in the observable universe, which means that everything that has happened on this small, wet, geologically unstable rock, every thought, every symphony, every act of love or cruelty or scientific discovery, every single thing that has ever been, conscious or felt anything, is a cosmic accident of such improbability that it borders on the miraculous. Which means that if we destroy ourselves, we are not just ending human civilization. We are potentially snuffing out the only conscious light in a universe that stretches for 93 billion light years in every direction. We are turning off the only lamp in an incomprehensibly vast and otherwise dark room. Or and this is the option that keeps certain physicists awake at night with a cold, sour feeling in their stomachs. Life arises readily enough, civilizations develop, and then something stops them. Something happens at some point in the development of every sufficiently advanced civilization that ends it. A filter, a barrier, some transition that once you reach it, you do not survive. And the question that changes everything, depending on the answer, is this: have we already passed through that filter, or is it still ahead of us? Pews, this is where Feynman's approach to physics becomes not just intellectually useful, but existentially urgent. Because the way you answer that question depends entirely on how clearly you can see reality as it actually is, rather than as you would like it to be. And seeing reality clearly was Feynman's obsession. His entire career, from his revolutionary work on quantum electrodynamics to his devastatingly honest testimony after the Challenger disaster, was a sustained argument for one principle: you must not fool yourself, and you're the easiest person to fool. Think about that. You are the easiest person to fool, not because you're stupid, not because you're weak, but because your brain is a prediction machine that runs on pattern matching and confirmation bias and motivated reasoning, and it has been doing this for hundreds of thousands of years, and it is very, very good at it. It will take whatever information you give it, and it will find a pattern, and it will find a story, and it will make you feel certain about that story, even when the story is completely wrong. And the universe, Feynman insisted, does not care about your story. The universe does not negotiate with your intuition. It does not adjust its behavior to accommodate your cognitive comfort. It simply is what it is. And if you want to understand it, you have to be willing to let it be stranger than you think, stranger than you can think, stranger than your entire species has ever thought before. And this brings us to the thing he discovered, the thing that sits at the heart of modern physics, the thing that he himself described as something nobody really understands, and yet something that has been tested to a precision that makes it the most accurate theory. In the history of science, there's a word for it, and I promise I'm getting there. But first, you need to feel the ground shift under you the way it shifted under Feynman when he first truly understood what the mathematics was saying. Look at the floor beneath your feet, or the chair you're sitting in, or your own hand right now. Pick one of those things and look at it. It feels solid. It feels definite. It feels like it is simply there, occupying a specific location in space, having a specific determined physical reality. Your hand is there in that place at this moment. That is just obvious. That is just how things are, except that it is not at the level of the atoms that make up your hand, and then at the level of the subatomic particles that make up those atoms, and then at the level of the quantum fields that make up those particles. The concept of things simply being there in a definite, determined way breaks down completely. Not slightly, not approximately. Completely. The electron in the atoms of your hand does not have a definite position until you measure it. It exists as a smear of probability, a superposition of all the places it could be, weighted by the mathematics of the wave function, and it only collapses into a specific location when it interacts with something else. And this is not a limitation of our measurement tools. This is not us failing to detect where the electron really is. This is the electron genuinely not being anywhere in particular until the interaction happens. Feynman used to say that if you're not shocked by quantum mechanics, you haven't understood it. And he meant that literally. He meant that the appropriate response to genuinely understanding what quantum mechanics says about the nature of reality is not intellectual satisfaction. It is a kind of philosophical vertigo, a sensation, something like standing on a floor that you suddenly realize is made of fog. The world is not made of things. It is made of events, of interactions, of probabilities that crystallize into facts only when they touch something else. And this is not a metaphor. This is the literal, experimentally verified, mathematically precise truth about the structure of physical reality. And yet, and here is that reversal again, the thing that looks like a problem, this fundamental indeterminacy at the heart of nature, turns out to be the very thing that makes chemistry possible, and therefore biology, and therefore you. The stability of atoms, the way electrons arrange themselves into shells and create the conditions for covalent bonds and molecular structures, the entire scaffolding of chemistry that life runs on, all of it depends on the quantum nature of the electron. If electrons had definite classical positions, they would spiral into the nucleus in a fraction of a second. Atoms would collapse and you would not exist. The fog is not a bug in the design of reality. The fog is the feature. The fog is why there's anything here at all. Feynman loved this. He absolutely loved it. He loved the way the universe turned out to be so much weirder and so much richer than human common sense could have predicted. He loved that every time you thought you had finally understood something, really understood it, the next layer down was stranger than the one above it. He used to describe the experience of doing physics as being like peeling an onion, except that instead of getting smaller as you peel, the onion gets larger. Every layer you remove reveals a larger onion underneath. And he found that intoxicating, not frightening, intoxicating. But here's where the beauty and the terror start to merge. Because the same universe that contains this extraordinary quantum machinery also contains the mechanisms of its own destruction and of ours. Let's talk about the things that could end us. Not in a catastrophizing, apocalyptic way, but in the precise, clear-eyed way that Feynman would insist on. The way a physicist looks at a system and asks, what are the actual failure modes here? What does the math say about how fragile this is? Bueno, start with the obvious ones: asteroid impact, gamma-ray burst, supervolcanic eruption. These are the extinction-level events that most people have at least a vague awareness of, and they are real. And they are non-trivial, and the fact that we have not yet developed the planetary defense infrastructure to deal with them is, from a Feynman perspective, a kind of collective irrationality that borders on the embarrassing. He would have had very little patience for a civilization that could write symphonies and split the atom but could not be bothered to track the rocks flying around its neighborhood. He would have found that darkly funny in the way that only the truly absurd can be funny. But the deeper threats, the ones that keep the cosmologists and the astrobiologists genuinely troubled, are not the ones we can see coming. They are the ones implied by the Great Silence itself. Because if there is indeed a great filter somewhere in the developmental sequence of civilizations, the most likely candidates are not external threats. They are internal ones. They are the failure modes that emerge from within a civilization that has developed technology faster than it has developed wisdom. Think about it this way. Feynman would have you think about it this way. Imagine a species that is, by any biological measure, remarkably intelligent. They have developed language, mathematics, art, philosophy, science. They have unlocked the secrets of the atom and the structure of DNA. They can communicate instantaneously across the entire surface of their planet. They can model the climate and predict the orbits of distant objects and sequence the genomes of every species they know about. They have, in short, developed extraordinary cognitive and technological capabilities. And now imagine that this same species, this remarkably intelligent species, is also deeply tribal, deeply prone to motivated reasoning, deeply susceptible to the appeal of simple narratives over complex truths, deeply resistant to updating its beliefs in the face of evidence that contradicts its preferences. Does that species survive? Does it solve the coordination problems that its technology creates fast enough to avoid the failure modes? Does it manage to look at the world as it actually is, rather than as it would like it to be, often enough and clearly enough to navigate the existential challenges that its own intelligence has generated? Aver. Feynman did not think this was a simple question. He did not think the answer was obvious. And he was deeply, genuinely worried about the trajectory of a civilization that increasingly valued performance over truth, that rewarded confident-sounding wrong answers over honest and uncertain right ones, that had developed an almost pathological discomfort with the admission of ignorance. Because admitting ignorance was, for Feynman, not a weakness. It was the beginning of everything. It was the first and most essential step in the direction of actually understanding something. He used to say that the most important phrase in science is not eureka, it is, that's funny, the moment of anomaly, the moment when the data does not fit the model, the moment when something is slightly, quietly, puzzlingly wrong. Because that moment, if you have the intellectual honesty to take it seriously, is where the real discoveries live. And this is where the great filter becomes personal. Not just civilizationally personal, but individually personal. Because the same cognitive habits that might doom a civilization are the ones operating in each of us every day. The confirmation bias, the motivated reasoning, the preference for comfortable certainty over uncomfortable truth, the tendency to dismiss anomalies instead of investigating them. These are not character flaws unique to other people. These are features of the hardware. They are running on your brain right now, and on mine, and on everyone's. And the only defense against them, the only tool Feynman ever found that actually worked, was the rigorous, disciplined, joyful practice of scientific thinking. Now, I want to tell you about a man who looked from every possible external perspective like someone who had it completely together. Let's call him someone in his mid-40s, successful by every conventional measure, confident in his views about the world, comfortable in his certainties. He had opinions about everything, and he held them with the kind of assurance that made other people assume he knew what he was talking about. He did not spend time with uncomfortable questions. He had no patience for ambiguity. When he encountered a scientific finding that contradicted his existing beliefs, he did not update the beliefs. He found reasons to dismiss the finding. He was, in the language of cognitive science, a textbook example of motivated reasoning. And on the outside, he looked fine. He looked confident. He looked like someone who had figured things out. And at the same time, inside, there was something hollow. There was a kind of intellectual loneliness that he could not name. A sense that the world was somehow less interesting than it should be, that everything had already been explained and there was nothing left to discover. He was, in a very real sense, living in a smaller universe than the one that actually existed. He had replaced the actual cosmos with all its strangeness and depth and terrifying beauty with a simplified model that fit inside the limits of what he already believed. And the simplified model was comfortable, but it was not alive. It did not buzz and hum with the electric charge of genuine mystery. It did not keep him up at night with the vertigo of real wonder. Feynman would have recognized him immediately, and he would not have been unkind about it. He would have been something more useful than kind. He would have been honest. He would have said, "You're living in a smaller world than the one that exists, and the door to the larger one is not locked. It has never been locked. It is standing open, and all it costs to walk through it is the willingness to say, 'I do not know and I want to find out.'" Pews, let's talk about what is actually on the other side of that door. Let's talk about what Feynman found when he walked through it, and kept walking, and refused to stop even when the landscape became so strange that the word strange stopped being adequate. One of the things he found was the nature of light, and light, it turns out, is one of the most deeply peculiar things in the universe. Not just interesting, peculiar. Strange in a way that should bother you if you think about it carefully enough. Light travels at a speed that is constant in all reference frames. Not approximately constant, exactly constant. Which means that if you're standing still and you measure the speed of a beam of light, and then you get in a spaceship and accelerate to half the speed of light, and then measure the speed of that same beam of light, you will get the same answer. The beam is not going faster or slower relative to you. It is going exactly the same speed. And the only way that can be true, the only mathematical way to make that work, is if space and time are not fixed, absolute things, but are instead flexible, relative dynamic features of a four-dimensional fabric that bends and stretches and compresses depending on how fast you're moving and how strong the gravitational field around you is. Einstein figured this out, and Feynman understood it so deeply that he could explain it to a child. He used to say that if you want to know what it means, just think about a clock. A clock is just a thing that counts oscillations of something. The oscillations of a pendulum or a spring or a crystal or the vibrations of a cesium atom. And when you move very fast, those oscillations slow down because the thing doing the oscillating is also moving through space. And the total speed through space-time is always the same. So more speed through space means less speed through time. You age more slowly, your clock runs slower. This is not a metaphor. This is a measurable, measured, experimentally confirmed fact. The GPS satellites in orbit above you right now are moving fast enough and are far enough out of Earth's gravitational well that they have to correct for relativistic time dilation every single day, or your maps would be wrong by several kilometers. Think about that. Reality is so strange that we had to build the strangeness into our mapping software. And most people drive around using GPS navigation every day without once thinking about the fact that the system works only because we correctly accounted for the curvature of space-time. Dejam pensar un momento, because this is exactly the kind of thing Feynman would want you to sit with. Not the technical details, but the implication. The implication that the world you navigate every day, the world that feels solid and commonsensical and reliably Newtonian, is actually resting on a foundation that is radically, irreducibly strange. And the strangeness is not something that exists only in particle accelerators or in the extreme environments near black holes. The strangeness is here right now in the atoms of your hand and in the light coming through your window and in the GPS coordinates your phone is calculating at this very moment. The strangeness is everywhere. We just cannot see it without the right instruments, without the right equations, without the right way of looking. And this is where Feynman's philosophy of physics and his philosophy of life converge into a single unified thing. Because the habit of mind required to do physics well, the willingness to follow the evidence wherever it goes, the refusal to protect cherished beliefs from inconvenient data, the embrace of uncertainty as a feature, rather than a bug, the delight in discovering that you were wrong because being wrong means you get to learn something. That habit of mind is not just scientifically useful. It is the only rational response to being a conscious creature in a universe this strange and this large and this indifferent to your preferences. Espra, let's come back to the silence. Let's come back to the great filter. Because now that you have some sense of what the universe is actually made of, the silence is even more disturbing than it was before. If quantum mechanics is correct, and it is the most precisely tested theory in the history of science, then the universe at its most fundamental level is not deterministic, it is probabilistic. Things happen because they are probable, not because they were inevitable. And if things happen because they are probable, then over the course of 14 billion years and across 2 trillion galaxies, anything that is merely possible becomes effectively certain to have occurred somewhere. The conditions for life, the self-replicating chemistry, the evolutionary pressure toward increasing complexity, the emergence of nervous systems and cognition, all of it is not just possible. It is on the scale of the observable universe almost statistically mandatory, and yet silence. The contradiction between the statistical expectation of abundant life and the observed fact of cosmic silence is so stark, so disturbing, that it has a name. It is called the Fermi paradox after that napkin calculation at Los Alamos. And the proposed solutions to it range from the merely unsettling to the genuinely terrifying. Maybe intelligent life is extraordinarily rare, far rarer than even the most conservative estimates suggest, so rare that we are the first civilization in the Milky Way to reach this level of technological development. This would be the rare Earth hypothesis, and it would mean that our existence is so improbable that it constitutes something close to a cosmic miracle. And it would mean that our destruction would be not just a human tragedy, but a universal one. Or maybe civilizations do arise, but they tend not to last. Maybe there's something about the developmental trajectory of technological civilizations that makes them inherently self-limiting. Maybe every civilization that reaches the point of being able to transmit detectable signals into space also reaches around the same time the point of being able to destroy itself. And most of them, perhaps all of them so far, chose or failed to avoid the latter. Or maybe, and this one is genuinely hard to think about, maybe there's something out there and it is not broadcasting because it does not want to be found. Maybe the silence is not emptiness, maybe it is concealment. Maybe the universe is not a quiet room, but a dark forest, where every civilization that makes noise gets eaten. Bueno, that particular hypothesis, the dark forest theory, is the kind of thing that tends to make people laugh nervously and then not quite be able to stop thinking about it. Feynman would have evaluated all of these hypotheses with the same tool, the data. What does the evidence actually say? And the honest answer is that the evidence is not yet sufficient to distinguish between them. We do not know whether we are alone by cosmic accident or by cosmic design or by the elimination of everyone who came before us. We do not know. And Feynman would have said, good, that is exactly the right place to be. That is the frontier. That is where the interesting work happens. But he would also have said, and this is the part that carries the weight, the fact that we do not know is not an excuse for not trying to find out. It is not an excuse for cutting the budgets of the telescopes. It is not an excuse for dismissing astrobiology as a fringe discipline. It is not an excuse for turning away from the hard questions because they make us uncomfortable. Because if there's a great filter ahead of us, if there's something that tends to end civilizations at roughly our stage of development, then the only possible way to survive it is to see it coming. And you cannot see it coming if you have decided, for reasons of comfort or ideology or tribal identity, that you're not going to look. This is what Feynman was really talking about in all those lectures and all those Caltech seminars and all those interviews where he sat with his characteristic slightly too wide grin and talked about the pleasure of finding things out. He was not just talking about physics, he was talking about survival. The survival of the curious, the survival of the honest, the survival of the people who are willing to say, I do not know what this is, and it frightens me, and I'm going to find out anyway. Now, here's the thing about the universe that Feynman found the most extraordinary of all. The thing that, when he really sat with it, made everything else feel like a warm-up. It is this. The universe did not have to be understandable. There is no logical necessity for the laws of physics to be the kind of thing that a human brain can grasp. The universe could have been governed by rules so complex, so arbitrary, so context-dependent and non-mathematical that no amount of intelligence could find patterns in them. It could have been irreducibly chaotic, fundamentally opaque, a blooming, buzzing confusion with no underlying structure. And it is not. It is at every level we have been able to examine mathematical. It is structured. It is patterned. It is, in the deepest and most literal sense of the word, comprehensible. And the fact that a 3-pound organ that evolved to help a primate find food on a savanna can, with sufficient training and effort, derive the equations that describe the behavior of particles at energies 1 trillion times higher than anything that organ will ever directly encounter. That fact is, Feynman thought the most stunning coincidence in the known history of the cosmos. And yet, and here it is one more time, that same comprehensibility, that same mathematical structure is also the thing that allows us to build the weapons that could end us. The same equations that describe the nucleus of the atom also describe the hydrogen bomb. The same understanding of biology that might one day cure every disease also makes possible the engineering of pathogens that no immune system has ever seen. The same technology that lets us communicate across the planet and build global scientific collaboration also lets us spread misinformation at a scale and speed that would have been unimaginable a century ago. The tools of understanding are also the tools of destruction, and which way they cut depends entirely on the wisdom, the honesty, and the intellectual courage of the people using them. Pews, this is the disturbing truth about reality that Feynman tried to explain. Not just one disturbing truth, but a whole nested structure of them, like those Russian dolls where each one contains a smaller and stranger one inside. Reality is not what it looks like. Not at the quantum level, not at the cosmological level, not at the level of your own cognition. Your senses give you a useful but radically simplified version of what is actually there. Your brain tells you stories about that simplified version and presents them to you as facts. The universe is almost certainly full of the prerequisites for life and yet appears to be completely silent. The filter that might end us is possibly still ahead. And the only way through any of this, the only tool that has ever actually worked for understanding reality as it is rather than as it appears, is the rigorous, humble, endlessly curious practice of following the evidence. But here's where Feynman would refuse to let you leave on a note of pure dread, because he was not a man who believed in despair. He believed in work. He believed in curiosity. He believed in the extraordinary privilege of being the kind of thing that can ask questions about the nature of the thing it is made of. And he would tell you with that grin, with that slightly manic energy that made his students feel like they were being let in on the greatest joke in history, that the disturbing truth about reality is also the most liberating truth about reality. Because if reality is not what it appears to be, that means the world is larger than you thought. It means there's more to understand than you imagined. It means the universe is not a closed book that has already been read, but an open one, with most of the pages still blank, or written in a language we are only beginning to learn, and that is not a reason for despair. That is a reason to stay curious. That is a reason to stay honest. That is a reason to keep looking up at the night sky, not with mild aesthetic appreciation, but with the full weight of what you now know pressing on your chest, the nuclear fires, and the quantum fog and the great silence, and the 14 billion years, and the 2 trillion galaxies, and the extraordinary, improbable, unrepeatable fact of your own consciousness. Aver. Let me give you the word now. The word I have been circling around since the beginning, the one that Feynman used to describe the fundamental condition of reality at the quantum level, the condition that has been verified to more decimal places than any other measurement in the history of science, and that remains, despite everything, something that nobody fully understands. The word is superposition, not in the casual metaphorical sense in which people sometimes use it. In the precise physical experimentally verified sense, the universe at its most fundamental level exists in superposition. It does not have a single definite state until it is observed, until it interacts with something else, and one of the possible states is actualized. Everything else, every other state, every other possibility is still there in some mathematical sense, in the wave function, in the probability amplitude, in the structure of the quantum field. And what that means, what it really means, is that reality is not a fixed thing. It is a set of potentialities that become actualities through interaction, through contact, through the act of one part of the universe reaching out and touching another. And here's why that matters beyond the physics. Here's why Feynman thought it mattered for the way you live your life. You are also in a kind of superposition. You are a set of potentialities that become actualities through contact, through engagement, through the willingness to reach out and interact with the world as it actually is rather than as you have decided it should. Every time you choose curiosity over comfort, every time you follow evidence into territory that contradicts your prior beliefs, every time you say, "I do not know," and mean it as an opening rather than a surrender, you are doing something that is in a very deep sense continuous with the most fundamental process in nature. You're collapsing a wave function. You're choosing one of the possible worlds and making it real. Feynman believed that the universe rewards this, not in a mystical karmic sense, in the precise practical sense that the people and the civilizations that are willing to see reality clearly are the ones that survive. They are the ones that build the technologies that work. They are the ones that find the filters before the filters find them. They are the ones that hear the silence of the cosmos and respond not with denial or despair, but with the only rational answer. We need to understand this, and we need to start now, and it is going to be the most extraordinary adventure our species has ever undertaken. He spent his whole life trying to tell us that. In the lectures, in the books, in the bongo drums, in the strip clubs, in the safe cracking at Los Alamos, in the way he treated every person he met as someone who was capable of understanding something genuinely difficult if you just found the right way to explain it. He was not interested in being the smartest person in the room. He was interested in the room getting smarter. He was interested in the species leveling up. He was interested in the possibility that this strange, improbable, temporary collection of atoms that calls itself humanity might actually be worth the 14 billion years it took the universe to produce it. And that, more than any equation, more than any Nobel Prize, more than any theorem or diagram or thought experiment, is the disturbing truth he tried to explain. Not that reality is frightening, though it is. Not that we might be alone, though we might be. Not that the filter might still be ahead of us, though it might be. The disturbing truth is that we have been given, for a brief and possibly unrepeatable moment, the capacity to understand where we are and what we are made of and how precarious our situation is, and we have a choice about what to do with that capacity. We can look away. We can choose comfort over truth, certainty over honesty, the small world of confirmed belief over the vast and terrifying and magnificent world that actually exists. Or we can do what Feynman did. We can look at the silence of the universe and decide that it is not a reason to be afraid. It is a reason to be curious. We can look at the quantum fog and decide that it is not a reason to despair. It is a reason to be amazed. We can look at the scale of the cosmos, at the 2 trillion galaxies and the 93 billion light years and the 14 billion years. And instead of feeling small, we can feel what Feynman felt. The vertiginous, intoxicating, almost unbearable privilege of being the part of the universe that gets to know about the rest of it. That is the disturbing truth. And it is also the most beautiful truth, and the fact that it is both, simultaneously without contradiction, is perhaps the most Feynman thing about reality. It is a superposition. It is terrifying and wonderful at once, and it only collapses into one or the other depending on how you choose to look at it. So look carefully, look honestly, look with everything you have, because the universe has been waiting 14 billion years for something capable of seeing it clearly. And you might be it, and you might not have forever to decide,